Hello dear students, welcome back to our channel. So today I have another very interesting problem for you all. And this is also from the ISI MSTAT paper. So this is the 24th problem of the PSA part of the MSTAT exam. And it says that we have a point, say UV, that is randomly chosen uniformly from the unit circle. So we have the unit circle that is of unit distance from the origin, and a point is chosen randomly on that unit circle. So as you all know, the region is denoted by this, the set of all small u and small v, such that the sum of the squares is 1, or in other words, the Euclidean distance from the origin equals to 1. So this is a circular region. So this is a circle having the origin as the center. Now what is the goal? Or in this problem actually, we have to find out the variance of the x coordinate of that point. Okay. Now we will make a very important observation here, that any point on our unit circle can be represented using polar representation. So suppose u and v is a point, then it is of the form u equals cos theta and v equals sin theta. So I think you all know this representation, and it actually helps us a lot to understand this problem. Because if it is been said that a point is uniformly located on the circle, that means we can actually choose the angle theta uniformly, and each such uniform angle will correspond to a uniform point on the unit circle. So suppose this is the origin and this is the angle theta. So this point is on the unit circle, right? Now here things are random. Since I have written small theta, that means it is some fixed theta, some fixed angle. But if it is random, to make it uniform, we have to choose uniformly the value of theta. Now that means we have to choose theta from the set of all possible angles, right? Now what are the set of all possible angles? That is nothing but 0 to 2 pi in radians. So that is exactly the key idea behind this problem. So if we choose theta uniformly from 0 to 2 pi, then uv, the corresponding point in the polar representation, actually gives us a point that is uniformly distributed on the unit circle, right? Now we just have to find out the variance of u. So now things are very easy, because now we will just apply the formula for variance and we will obtain variance of u equals expectation u square minus expectation square of u. Now u is following u is equal to cos theta and theta is following uniform. So again we can actually compute these expectations very easily as follows. We can see expectation of u is nothing but integral of cos theta from 0 to 2 pi times the uniform PDF. Now this will be 0 due to periodicity of the function cosine, it will be 0. And similarly, you can find out expectation u square. That will come out to be half. And that is exactly the value of variance of u. Okay, so actually, this is the end of the problem. Wasn't it very simple, right? So the answer should be B. I have something more for you all. So this is a bonus. Now this is a very interesting observation if you make, that for the coordinates, I mean x coordinate u and y coordinate v, if we calculate the expectations individually, we get both to be equal to 0. It's very simple, you all can do that. Now that implies, yes, so that is actually a problem, because that means if we are calculating mean of random uniform observations on the unit circle, then that is on the origin. Now that actually doesn't make sense. Now by mean of random uniform observations, I mean in the sense of law of large numbers. So if you have enough number of observations, as you all know, the sample mean can approximate the actual population mean. But in this case, that is tending towards 0. That actually is not what is expected. Why is it so? So the reason is that we are taking points uniformly on the circle, right? But that means the circumference of the unit circle is the support. Observations should come from that circle or on that circle only, not inside that circle or outside that circle. But the point origin is obviously not included in the circle, right? It is not lying on the circumference, it is inside the circle. So the mean, if we calculate the coordinate-wise mean, that will go out of the support of the random variable. So that is the key problem. And actually, I have some simulations for you also. So this actually looks very nice. So suppose we have this unit circle. Now we have a uniformly random point on the circumference. Suppose this is one point. Okay, this is another. Okay, in this manner, we can keep on getting more and more observations, right? Okay, suppose we do that for, say, 20 times. So we get 20 observations. So these are all these observations. Now, as you all know, we can calculate the sample means in the same manner, right? So expectation cos theta and expectation sin theta will now be just like the sum of the individual angles, right? So if we do that, we will obtain this as the new mean or the coordinate-wise mean. But as you all can see, it is not making any sense because it is outside the circle itself. So now the question arises, what then should be a good idea or a good notion of mean for this kind of problems? So one thing, as you all can see, we have more observations over here, and that is the reason this point is also inside those observations, or I mean, they are lying inside those lines that I have drawn, that is joining the origin and the corresponding observations. So that kind of actually works as a same measure of central tendency, right? But there is one problem, that it should lie on the circumference. So this is the basic idea. Now, the idea is like, we have a unit circle and we are taking points randomly. So each point corresponds to a random angle. So here also we will calculate the average angle of this point, and we will correspond, or we will project that angle on the unit circle and obtain the average of this circular observations or these observations on the unit circle. So this kind of things or this kind of ideas are addressed in the field called circular statistics, where we have random observations on the circumference of a circle or sphere or high dimensional, this hyperspheres and things like that. So that is a very interesting area of research in statistics. And the main idea that behind our problem is like, we have suppose some n observations which are n points, and for each of those points we have corresponding angles as theta 1 up to theta n. Then what should be the average of these observations? The answer is this. So this is called the circular mean direction. Now that is given as the argument of this complex number. So as you all can understand, basically we are just adding the y coordinates and the x coordinates. And the x coordinates are like this thing, sum of the cosines of each angle, and the y coordinates are the sum of the sines of each angle. Now that will give us the x and y coordinate, and we have to find out the argument of that point. So in terms of complex numbers also, we can define it as the argument of this complex number. So that will give us the mean circular direction. So yes, I think this connection was interesting, and I thought of sharing this with all of you. Yes, so that's all for this video. If you like this, please do consider sharing it with this video with your friends. And also, I wish you all the best, and I hope that you will see other videos in our channel as well. Hare Krishna.